Good afternoon. Welcome to Ravi Tuitions and Dear Teacher. So, yesterday I have started teaching geometry, theorems in the chapter Quadrilaterals. So, I have been teaching 10th class in the morning time 6 o'clock to 7 o'clock. Since maybe more than 5 months I have been teaching. I started 9th class at that time also, but because of the inconvenience, timings did not match to take the class. Now I tried to match this 4 o'clock time. So yesterday onwards I have started teaching. Theorems. So now yesterday I taught theorems. I taught few theorems. Now I am going to teach the other theorems. I am teaching completely from the NCERT textbook. Okay. So now let me start my teaching. So very important thing, all these things are acts like basics. Okay, these basics are very important, right? So these basics are very important, and yesterday I taught few theorems. Now I am going to teach few more theorems, right? So in this lesson a very important theorem, midpoint theorem, is there. So before that I am going to do 8.6 theorem number 8.6. Theorem number 8.6. The diagonals of parallelogram bisects each other. The statement is diagonals of parallelogram bisects each other. This is the statement. The diagonals of the parallelogram bisects each other. Okay. So now this is you can remember this like a property also. For this we will take a parallelogram. Let me take a parallelogram here. Okay, this is a parallelogram. Name it A, B, C, D. So opposite sides are parallel in parallelogram. So now our thing is given. ABCD is a parallelogram. Now what we have to prove? The diagonals bisects each other. So now let us draw the diagonals. join A and C and B and D. These two diagonals are meeting at O, and these two diagonals are intersecting each other, bisecting each other. That means this AO is equal to CO. Bisecting means making it into two equal parts. At the same way, BO is equal to DO. So now what we have to prove is AO is equal to CO. This is one, and the second one is BO is equal to DO. Okay. Now for this, let us take proof. Okay. Now you take any two triangles, opposite triangles. They take these two triangles in triangle AOB and triangle COD. These two triangles. Prove that they are congruent. How they are congruent? Okay. How they are congruent? Because it is a parallelogram, alternate interior angles are equal. Angle 1 is equal to angle 2 and angle 3 is equal to angle 4. These are alternate interior angles. As AB is parallel to CD, angle 1 is equal to 2 and angle 3 is equal to 4, because they are alternate interior angles. So now AB is equal to CD, because opposite sides of parallelogram we have proved they are equal. Therefore, triangle AOB is congruent to triangle COD by ASA congruency rule. So ultimately we have to prove that AO is equal to CO. So now CPCT, because 1 and 2 are equal, so CPCT you can take corresponding parts of congruent triangles by CPCT. So 1, 3 are equal, 3 opposite side is AO, and AO is equal to CO and BO is equal to DO. So that is what is to be proved. Okay. So a very important theorem, easy theorem also. Mostly in the parallelograms, mostly theorems are available. Very less number of problems are available. So now let us go to the converse of this statement. Okay. 8.7. 8.7. That means what is the converse? Converse is 8.7, the diagonals of quadrilateral bisects. The diagonals of a parallelogram bisects, then the quadrilateral is, I am sorry, this is not quadrilateral. This is not a parallelogram. Diagonals of quadrilateral bisects each other, then లేదు ఆన్లైన్లో నడుస్తాం. చెప్పు, డబ్బులు కావాలా? చేసే దా, అవి సరిపోయే డబ్బులు ఇదిగో. So each other, then it is a parallelogram. That means the quadrilateral is a parallelogram. That's what we wanted to prove. So for this we have to take a quadrilateral which looks like right? This is a quadrilateral ABCD. As we have to prove this as a parallelogram, you should draw like a parallelogram, okay? But it is not a parallelogram now, it is just a quadrilateral, okay? So now let us write given ABCD is equal to a quadrilateral, and the diagonals bisect each other. That means the diagonals we have to draw. These two diagonals are bisecting each other. Bisected. So that means AO is equal to CO and BO is equal to DO. In this quadrilateral, the diagonals bisects. So then what is RTP required to prove? ABCD is equal to a parallelogram. So to prove any quadrilateral parallelogram, we should prove that opposite sides are parallel. So let us try to prove AB is parallel to CD and BC is parallel to AD. This is our target. So now prove. Again in this case also we will take these two triangles, right? So now because AO is equal to CO given, BO is equal to DO given, let us write in triangle AOB and triangle COD. AO is equal to CO, this is given, you can see this is given, and BO is equal to DO, this is also given, see you can see, and angle 1 is equal to 2, angle 1 is equal to 2. So these are vertically opposite angles. Therefore, triangle AOB is congruent to triangle COD by side angle side, SAS congruency rule. Therefore, by CPCT, corresponding parts of congruent triangles. So what are the corresponding parts of congruent triangles? Let us see angle 1 and angle 2. So angle 1 is equal to angle 2, this is CPCT, and that implies AB is parallel to CD. So this is 1, because 1 and 2 are alternate, they are alternate interior angles. So now we have to prove the other also. BC is parallel to say AD. So similarly we can prove BC is parallel to AD. That implies ABCD is equal to a parallelogram. This is another theorem. Okay. Now let us see what else he has given. Now he went to directly the problems. Let us go to the problems. 8.1 exercise. Okay. 8.1 exercise. Chip. What's that?